Well, I just might make it. Let's go ahead and slide on down here. We'll do our last example. Our last example, actually before we get into that, let's remind ourselves how to find the arc length. And you should remember the arc length formula from the rectangular, meaning y is a function of x. And you should remember that, let's draw a little picture here. If we draw a curve, and let's label this curve y equals f of x, and if we wanted to find the length of the arc, then you should remember that what we did was we actually just found the length of an infinite number of line segment lengths. Okay, or we added up an infinite number of line segment lengths. And zooming in on this, if we make if we want to just figure out what the length of this line segment is, we can make a right triangle, and if you remember this dx there and a dy there, and we said that s squared is dx squared plus dy squared, and then if we wanted to find the actual length of s, we would square our dx and add to that the square of dy, and then if we wanted to find the total length from from x equals a to x equals b, so if we want to find the length there, we would say L is equal to from A to B, and we're going to integrate, because when you integrate, you add up an infinite number of things. Okay, and those things that we added up were line segment lengths, and that's where we get that formula. Now, the formula simplifies to something else involving dy and f prime of x squared 1 plus. So it simplifies to this 1 plus f prime of x squared dx, and we could do that, but anyway, this is where this came from. Okay, this guy right here came from this. You should check your 7.4 notes if you wanted to remind yourself where that came from. This is usually something we memorize. Okay, but this guy right here is our bread and butter, because this dx and dy don't depend on t. This is just derivative of x and derivative of y. Excuse me. And we can use this to relate to parametric. Sorry, a little pause in the brain there. So parametric arc length, and I want you to watch this because it's going to be a lot different. The arc length in parametric is the integral from a to b of the square root. Now again, it looks a lot different than it did over here because I drew it in black. And so if you look at this, maybe I'll zoom out a little bit so you can see them both at the same time. dx in parametric is the same thing as x prime of t, or dx dt. So where x prime of t equals dx dt, and normally you see it like the way you see it here. We're going to square that, and we're going to add to that y prime of t squared dt. So this you don't have to do any sorry, you don't have to do any adjusting to. You just leave it like that, and that is your length of an arc in parametric mode, where again x prime of t is the same thing as dx dt, and y prime of t is the same as dy dt. Okay, and so there you have it. This is a very, very important formula, but if you've been learning integrals as we've gone along, adding up an infinite number of things, then this is just one more application of that concept. So let's take a look at our last example, which is to find the length of the curve. Okay, so find the length of the curve. And that's what we're going to do. We're going to find the length of the curve. And the curve is represented by the parametric equations x equals, now they're going to look kind of funky here, 2t plus 3 to the 3 halves. And they have to construct these a certain way so that they work out well if you don't use your calculator. So we're not going to use the calculator on this one. T plus t squared over 2, and we're going to find the length of the arc from t equals 0 all the way to t equals 3. Sorry, I think that was a little crooked for you. Okay, so the first thing we're going to do is we're going to remember what our formula is, and so we get the length of the arc, is equal to the integral from 0 to 3 of the square root of, and I urge you with great passion to write this down, because you'll forget little things and then you'll be sorry. So this is what we have, and what we're going to need to do is figure out what x prime of t is. And so let's do that. X prime of t is equal to, let's take the 3/2, multiply it by the inside to the 1/2, multiply that by the derivative of the inside, and then divide that all by 3. And I could have multiplied by 1/3 as well. Well, if you want to do the math, great. Cancel the 3's, cancel the 2's, and all we get is the square root of 2t plus 3. Okay, so that's x prime of t. But I need x prime of t squared, so I'm going to do that out here. X prime of t squared. So I'm going to square both sides, and I can see that I just get 2t plus 3. Okay, and then I need y prime of t, and I'll start with just y prime of t is 1 plus 2t over 2, 1 plus 2t over 2, which is just 1 plus t. Now, if I square that, then I get 1 plus 2t plus t squared. Okay, and now I can just go ahead and go over here. The integral from 0 to 3 of, now I can put in these guys. 2t plus 3 plus, and then we have t squared, I'll change the order here, plus 2t plus 1 dt, which we get, if you simplify things a bit, you get t squared plus 4t plus 4 dt, and then you can see that's t plus 2 squared. Square root of t plus 2 squared is just t plus 2. That's why I said it starts out kind of interesting, but it always works out. If they make you do it by hand, it's going to work out really easily. Okay, so then the antiderivative of t plus 2 is t squared over 2 plus 2t, evaluated from 0 to 3, and you end up getting 9/2 plus 6, and that is 21 over 2. Did I get that right? 12 and 9 is 21. Yeah. So 21 over 2, and that is your last example. The work that I'm going to have you do is just going to be done in class. Okay? So hopefully you had a chance to do these tonight. I'm sorry for the last minute notice. And if you have time, hopefully you've been able to watch these. If not, you're watching these in class, you'll still have plenty of time to talk with each other and then do the work and not have to take anything home. But hopefully check Canvas for more videos for tomorrow. Have a great day.